So just to go through it again, sorry. Value of n is the overall expansion, so we get that using this number. So n is 10. P and Q, well, it's p to the power of 6 times 2q to the power of 4, so that would be a and b, right? So a is a to the power of 6 and b to the power of 4. So that's a is p and b is 2q. And an expression for the 6th term. Now they've given you a bit of a clue in the question to avoid the common mistake. I'm sure you haven't, because you didn't last time. So what did you write? So we've got 10.
You can't put me on blast like that. 10, 6.
Oh,
No,
yeah.
4.
No. 10, 5. Yeah, the common mistake is to put 10, 6 for the 6th term. But they gave you a clue, look, the 5th term is 4. Just to kind of remind you. Because the first term would be 10, 0. And then it's 10, 1, 10, 2.
Are you just talking about
Say it again.
for the answer, it's like A equals P, should we P instead?
No, so A is just P, and because remember it would A to the power of 6 times B to the power of 4, so A is whatever was to the power of 6, so it's just the P. If you wrote P to the power of 6, you wouldn't get it actually.
How come you didn't write P plus 2Q?
Because it just wants what A is and what B is. You could, if you'd have written P plus 2Q to the power of 10, I'm sure they probably would have credited you the marks with knowing that. Because you basically stated that A is P and B is 2Q. But what they actually want is write down A in terms of P. So I want A equals and B equals. So that's ideally what they want. So you might have lost a mark, 1 mark. If there was, if there's only 1 mark or 2 marks, you'd probably get it. But back to part C, unless you've got more questions on A and B. No. So we've got the 10-5 bit, which then leads us to the rest of it. So we would have P to the power of, sorry what? 5. And 2q to the power of 5. Okay. But we do need to question. Do we need to simplify? Well, it says here the 5th term in the expansion is given by, there's an expression, write down an expression for the 6th term, so probably no need at this stage, and that is what they expected the answer. If you did go ahead and sort of do 2 to the power of 5, and there's just no need at this stage. Right, just ask for the expression. So we don't need to convert 10 to the power of 5, because actually this is an expression for the 6th term. If I were to convert that to an actual number and simplify, that would give me the actual term rather than an expression for the term. Any further questions on that? No? Okay. Was it a bit easier than you initially thought?
Yeah.
Yeah.
Where is this the P to the power of 6 dot that?
Yeah, that's a times, yeah.
Which one is that for? A or B?
B. Okay, got another question. So it gets slightly harder now. So let me maybe write it a bit bigger for you. So it says, consider the expansion of, that's an x cubed over 2 plus p over x all to the power of 8. And it's telling you the constant term is 5103. So the constant term means 5103 is all there is. There's no x's and everything. It says find the possible values of P. So what do you need to try and do first? Find the term where... Pardon? No.
Which one do you get the 5 1
Yeah, well, which one's going to be constant? Our focus, if we're going to find the constant term, when
when the powers are equal to each other?
The powers of what?
The x and
the x's. Remember, I need... When I get a constant term, it's because I've got an x on the top and I've got an x on the bottom, so they will eventually at one point cancel each other out when you multiply them. So you've got to figure out what that point is, and then that can tell you the coefficient and so on. So it's this constant term. We've done a couple like these. So I'll let you have a go, see whether you can do it first.
Wait, what term is that one that they've given us? 0?
No, this is the expansion that I want to do. I've not given you any terms. Remember, when I do the expansion, I work out the terms, there won't be a plus in the middle anymore. It'll be this times this.
Okay.
So do you remember when we first did a
zero?
question like this? You started off by doing every term in the expansion and finding which one got rid of the x's. What we would like to do now to cut the time back is to know and go straight to the term where the x's disappear, where they cancel each other out. So you need to figure out which one it would be.
What term is that one?
That's not a term, it's the whole thing. It's
like, you know how it's a plus b
Yeah.
to the power n? That's just like an a plus b, but it's in fractions.
Yeah. Do you remember at the very beginning we had a plus b to the power of 2 and we expanded the brackets, and then I said a plus b to the power of 3 and then we expanded the brackets
Like, I
again.
know that like the x's have to have like
Yeah,
to the power
but
of
this
4
is-
to the power of 4
well,
to cancel out,
but it might not be, because remember this has already got an x to the power of 3.
Oh.
So you can't just split that in half. You've got to be a bit more imaginative maybe.
So that 3 can't change into another number.
Well, remember when you do the expansion, this 8 will be split into 2 parts, and we'll have that bit to the power of something times that bit to the power of something. And however you split 8, you're going to multiply that, or raise to the power that bit, and then you multiply the powers. So when you multiply the powers for this one, it has to equal, like you said, power of this one. Right? But it's not going to be 4 and 4 in this case.
Yeah.
If there was no power of 3, it would be 4 and 4. But because there is a power of 3, you've got to think about it. Yeah. Right, let's go through it. So if you're not quite there, slow me down. Make sure you've got it. Alright, so I want a constant term. Now constant, oh it's wet there. The constant term, when it says constant, it means there must be no x value in the term. No x in the term. That means the only thing is it's 5103. So you'll always get this no x in the term when we've got x's top and bottom of a fraction, so the numerator and the denominator. So they're going to cancel out. So you can, like a couple of you have been doing, work out the whole expansion and figure out, or the quick way to do, as they would hope you would do, is you would say, right, it's 8 over something. I know it's 8 because of this number here. And then it's going to be x to the power of 3 over 2 to the power of something. I'll tell you what, should we try and do it algebraically?
No.
Well, I'm going to say this would be n minus r. Do you recognise that from before? So 8 over r, and then it would be p over x to the power of r. Yeah? Right, so I'm trying to give you, for those people that are not quite getting it, I'm trying to give you another, maybe an algebraic. Right, so what do I do then? So when I do this expansion, I'm going to have x to the power of 3 times n minus r over 2 to the power of n minus r.
Do we not put the line in the last line?
Say it again.
The line in the last line?
Yeah, I just did. Okay, so I've got that bit, and then I need to times it by p over r and x over r. Right? So that's what I'm doing. Now, what needs to happen? What needs to be true for this to be a constant term? Not the x's, but the well, the powers of x's need. So what we're saying is this, whatever this is, has to equal whatever that is. Yeah? Does that make sense? So we've got 3n minus 3r has to equal r. What do we have in this case? We have 2 unknowns and 1 equation. What do you need? So I'm kind of giving you a different method here. You might decide, actually, this is far too complicated. I like just going straight there. But test your other math skills. I've got 2 unknowns in an equation. How do I solve simultaneous equations? Is there another equation I can write?
2r, 2n minus r, minus 2r.
Oh, could you write x?
Yeah, 2n
x
minus
r
2.
and then other x.
2n minus 2r. Why would you do 2n minus 2r?
That's the other unknown, and that's the other power.
Oh, but I've only looked at the powers separately rather than just...
How do you even get 3n minus 3r?
So would it be n minus r?
But this one doesn't have to equal that one. Are you all getting that? This doesn't equal that one. All I do know is that this one has to equal that one for the x's to cancel out, yeah? So that's, do you understand 3 lots of n, 3 lots of r, yeah, expand the brackets, is equal to r. What else must be true though?
R must be
Well, there's actually something I can say straight away. N equals
8.
8. How do I know that? Okay. I didn't rearrange, I just know that n is equal to 8. I've not rearranged, I just know that n is. So then I've got 24, 3 times 8, minus 3 r's has to equal r.
6.
So now I can rearrange. So I've got 24, if I add 3 r's, has to equal 4 r's, which means r equals 6. Okay. Now how does that help me? Well, that helps me because now up here I can say that's 6 and this bit is equal to 2. Alright.
Can I take a picture of that?
Well, it's on a video.
Alright.
You can go through it. I've noticed you have logged on and looked. It's good. At least you're using it. I can do that, by the way. It's Firefly. It's great. I can log on and know exactly who has looked at the videos, what time they looked at it last and everything.
That's so weird.
I know. I'd hated being a student when yeah, I looked at it. No, you didn't. Right, so we've got that. Is that maybe, for those of you that couldn't quite get it, is that maybe a better method to apply, or? Yeah?
Why would they use like R and
Oh my god.
Why did they use A and B?
N? No, but like R and N are like, they're like,
N for the number of the expansion. And
no, because I keep writing my N's as R's and my R's as N's.
oh, so.
So when do we use that equation with the exclamation mark?
Well, okay, so at this stage, before we answer that question, I now know that I've got x over 3 over, what was it again? 2. All of that had to be to the power of 2, and the next bit was p over x to the power of 6, and I know it's 8, but it's 8 what?
2 or 6.
2 or 6. Doesn't matter. One of those two numbers. They're both the same value. Alright? Now, just to show you that that will be the constant term, well, if I expand, so the power and the power, so I've got 8, 2, and it becomes x to the power of 6 over 2 to the power of 2. Don't fall into the trap of saying it's 2 to the power of 6, because you would make a mistake. Okay? Times p to the power of 6 over x to the power of 6. So this is the stage where we go, look, my x's cancel out. So what I'm left with is 8, 2 times p to the power of 6 over 4. And that equals 5103, because that's what I was told in the question that the value is. So now I've got the information required to find what p is. So my first step was just being able to eliminate the x. Right, so how do I find this value in my calculator? If I wasn't allowed my calculator,
The equation.
my equation. So if I want to find out the value for 8, 2, I could do, was it 8 factorial over 2 factorial times 8 minus 2 factorial? Yeah. So that would be, should we do this as a practice? Because you would use your calculator at this stage, but let's do this as a practice. So that would give me 8 times 7 times 6 times 5. 4 times 3 times 2 times 1.
8 over 6.
All over. You can use 8 over 6 if you'd rather.
2 because it's just 2 times 1.
Yeah.
Oh, look. Wait, what did you say this is again? Okay.
So I've got 2 times 1 for 2 factorial multiplied by 6 factorial, so it's 6 times 5 times 4 times 3 times 2. It actually won't make any difference, Harley, because if that was 6 factorial, this would be 8 minus 6 would be 2 factorial. You end up with exactly the same thing.
So I can copy that, I'm sorry.
Yeah, exactly the same. If you wrote, well, actually, I would have it the other way around, but yeah, it's fine.
It starts with 1.
No, I would have 6, 5, 4, 3, 2, 1 times 2 times 1 if I did it 8, 6. That's all.
Equals 28.
Right, so cancel that down. 2 times 1. I'm going to change that one to 4. Okay. Cancel the 8 with the 2. The 6 times 4 times 3 times is that. That's all gone. So now I'm left with 4 times 7. So it's 28. Okay. So it's not that hard even without a calculator, is it?
Wait, how did you get rid of the 2 times 1?
2 times 1 is just 2, and I cancelled 8 with 2. Yeah. So now I've got 28 times p to the power of 6 over 4 equals 5103. Well, 28 over 4 is 7. So I've got 7p to the power of 6 is 5103. If you want to carry on, by the way, if we're finishing, go on, if you've got a question.
Why do you have it all in one line? It's supposed to be divided.
I don't know why it's not. I found all of them, okay?
But how do I get then those people that still work? How do I get from 7p to the power of 6? Divide by 7. So p to the power of 6 is, can someone do that for me? 729. And then I find the 6th root of 729. So to the power of 6, 729. So p is 3. However, always when you're doing an exam, get your answer, what you think is your answer, and go back and read the question. Because the question asks, what are the possible values of p? Which would suggest you're going to have more than one answer. And I've only got one answer, so I'm going to have not gained all my marks. So, I've got a power. That brings in what into play?
A negative and a positive.
Negatives and positives. Did you get that, girl? Or are you going to not get that? Both of you. Yeah. I know, but I said, do you understand where the second answer comes from? Cassie just told us, yeah? What's the second answer then?
I'm just trying to figure out the first answer.
You could make this over.
Well, let me know which bit you're stuck with. Rather than do it between you.
No, I figured it out.
Oh, you have it, okay.
Got it.
Yeah. Can I finish this one with everyone and then I'll come back to it? Okay. So what's the second answer? Pardon? Negative 3. Why is that?
It is.
But it's like when you square something, 3 squared and minus 3 squared are the same answer, yeah? And it's when you have an even power, so 3 to the power of 6 and minus 3 to the power of 6 will give you the same answer. Alright? So that's why we have to consider the negative answer. If this was an odd power, if it was p to the power of 5 equals something, then there is only one answer, isn't there? Right? It's because I've got an even power that I've got a second negative answer. Okay.
Why do we have the 4 instead of the 8?
Because I cancelled the 8 with the 2. So 8 divided by 2, so it gets rid of it, is 4. Yeah? So maybe if I say, so the 8 cancels with the 2 to give the 4. And then this all cancels with that. So I'm left with only my 7 and the 4. Right. Any other questions on that one? Plenty of marks to earn. Right, the next question then.
Would you have that expanded first?
Right, so we've got the question. Everyone, even those that take the out now, would you expand it first?
I say, I don't know, because I've tried both ways.
Do you remember last time we met, I gave you that question where it was 3x plus 4 in brackets multiplied by the expansion. Do you remember I said to you, there's a couple of questions we've done where they ask you to find a specific term first, and then part B is now work out this term, and you have to realise that it's carrying on. But I also said, to make that question harder, they could not ask you to do the initial bit. And the first term, it's just like find to the power of 4, find the expression in x to the power of 4. They haven't asked you to do that because they want to make it just a little bit harder and check your understanding, and you need to figure out.
Wait, this relates to the last question?
No. Ones we've done before. Alright? This one you have to realise what it's going to be. So you're going to do it in 2 stages. So you need to first of all figure out which term in that expansion you need, which then when you multiply by x squared afterwards gets rid of the x values to give you a constant term. Okay, so you need to think about which term in the yellow expansion you need to find, that when you multiply it by x squared afterwards, you then get rid of the x's. So what you're thinking is we're going to have an x squared times the term in the expansion. What do we want in this so that when I multiply by x squared I get rid of the x's? What does it have to have in this bit? Not an x squared, but I'd say not an x squared. Yes, it has to be an x squared, but where is that x squared?
On the bottom.
On the bottom. So I'm going to have something with the x squared underneath. Alright? So that means...
So the k with the x, k over x, that x is going to have to be x.
Well, actually, after I've done the expansion. Now, if I look at it then, that means if I get left with x squared, so if I do it as the times bits, if I get left with something over x squared, that means on the top and on the bottom, how is it going to be split? So it could be x squared on the top with x to the power of 4. So if I have that, that will leave me with the 1 over x squared bit, yeah? Yeah? Because then that will cancel with that. Now, it could also be x to the power of 3 and x to the power of
6, 9.
so 3,
5.
5, isn't it?
Oh,
Because I want left with 2.
Because they subtract.
They subtract.
They don't divide.
Yeah.
Which one subtract?
They're like
The powers.
So when you divide powers, you subtract them, don't you? So this 5 will, 3 of those will be taken, and you're left with 2. Right? It could also be. What could the other option be? It could be x to the power of 4 and x to the power of 6 and so on. Now, what we then do, obviously in the exam, you're not going to write out all these options. This is what's going on in your head.
X to the 6 and x to the 8.
It could also be x to the 6 and x to the 8. But what we need to figure out is, yeah, okay, let's consider it. X to the power of 6, x to the power of 8, sorry. Which one can it be? So for instance, when we do our expansion, because this is an x squared already, alright, this has to be the result of x to the power of 2 times something.
Where does the 3 go?
So this could be to the power of 1, but then this would have to be to the power of something,
Negative something.
and this would have to be a 7, but 7 times what would give you the 4? Nothing. So it can't be that one.
Where does the 3 go
What 3?
in the
The
expansion?
3x squared with the...
Oh, I haven't dealt with that bit.
But he just hasn't put it there, but it's
I'm
still
just considering the x's at the moment. I just want to know the x power, the powers, and I can do that just with the x's. What about x to the power of 3? Can I get, so that would have to be x squared to the power of something to give me x to the power of 3.
No.
Sorry, that can't. So that one's out of action as well. This one would be, well, it'd be x squared to the power of 2, which means this would have to be to the power of 6. So that would have to be x to the power of 1.
But that doesn't work because you have to have a square. Right?
No, remember I need a 6. So if I do the 6 to the 1, I actually get the 6 that I wanted.
Oh, so that will work?
So this would work, wouldn't it? Because that would end up being
X to the
x to the power of 4 over x to the power of...
Why are you squaring them again? Like it's already x to the 6 to the power of 6. So why are you doing
It's not x to the power of 6. It's... I want x to the power of 6 and I want x to the power of 4. And this gets it, yeah? If I start with x to the power of 1 and x... Okay? Does that give me what I... Well, I've got x to the power of... Right?
But what does that get you then? Why is it a 4 and a 6?
Well, what that's done now...
4 and 6 has made it so that it can cancel out. So
Yeah.
the squares can cancel
So I can kind of forget that one.
But I thought they have to be the same power to cancel out.
What? No, I don't want them to cancel out completely now, do I?
You want them to equal x squared.
I have to go back. If I think back to where I want, I need it to be an x squared left on the bottom with the first expansion. Alright? So
those two can cancel out?
I've determined... Oh,
So it's going to be 3x squared.
so I've determined from what I've just done that what I need is the term to be x squared. I need it split x2, x6. Alright? Does that make sense?
Yeah. So is it 3x squared?
So what that means then, yeah, like you say, now we've got, it's got to be 3x squared to the power of 2 times, what was it, k over x to the power of 6. So that's the one that I've determined I need.
So is there nothing?
And the coefficient will be
8 over 2. or
8 over 2 or 8 over 6 again. Alright? So I'm just going to delete all that. That would have been going on in my head.
So this.
Because I'm very well practiced. I've done a lot of homework, I've done a lot of practicing. I'm really ready to
And
make
you don't do, like,
I've not been doing
crazy
binomial expansion just for a couple of weeks. I've been doing it regularly. So I would have been doing it in my head. At this stage, you'll be doing it on paper.
Yeah.
By the end of the course, you'll be doing it in your head. Yeah? Yeah, you will. I've got 100% faith in all of you. Right. So what does that mean? Well, I know because of all the questions I've been doing, 8 over 2 is 28 already. I know it's times 9x squared
You really need some help. 9, isn't it?
times k to the power of 6 over x to the power of 6.
Why is that x to the 4?
Sorry, yeah. Good spotting. That means I can cancel that, leaving just the 2. So I now have, very nicely, do you know what 28 times 9 is for me?
Can't you do it in your head?
Yeah.
A4.
Pardon?
84.
All the
84.
homework you've done.
28 times 9?
And then,
That's 252.
I was going to say,
How did you write that?
because you told me, what is it? It's 280 minus 28.
252.
252, and it's times k to the power of 6, and it's all over x squared. Alright? Now, go back to my question. It says consider the expansion of the constant term. Now, if I do this next bit, the times through by x squared, which is what I've been waiting to do, I have to multiply through by x squared. And luckily, that gets rid of that. So now it's a constant term. And I'm told it's 16128. So I now know that
Where did the x squared come from?
Because you had to multiply it.
the very beginning question, the question up here, look.
Oh, I see x.
So just to colour code it,
So 252.
so all of this, so this bit and all of this was to find the yellow bit. Now what I'm working on here, that was bringing in the pink bit. Alright?
So Mr. Fox, 252 times k to the 6 is equal to 1,600.
16128. Yeah.
And we divide by 6.
So k to the power of 6 is?
Negative 52. I mean,
64.
64?
No, because you got to square
oh, you have to
root it by
subtract it
6.
from that big number.
He's still doing k.
Division. K to the power of 6. So therefore k
Oh,
is
you were doing that?
K
Four.
is
Oh, now I'm making up numbers. 2.
2. Now I've got a question for you here. Why did they not ask for the 2 possible values of k?
Because it's not 2.
You can't have a negative on top of the fraction? I don't know.
Yes, you can. Why here?
Because they
Look,
were already mean, so they didn't want
because we've got plus k here, and this one was
Oh, that one was a division.
plus p. This time, find the possible values. The answer is
Minus, there's plus and minus there.
Oh wait, no, K is over something as well. I don't know. You tell us.
You tell me. Well, that's what I'm saying. Couldn't it not be minus 2 as well? Why didn't they ask for the 2 possible
They
values?
were already mean, so they didn't want to be meaner.
I would, yeah, potentially. Potentially. They've kind
But
of,
it could be k, they could be negative 2. Right?
Yeah.
K could be negative 2.
yeah. Okie doke.
could have asked.
Yes.
They don't want to